multiple surfaces or gaps for removal. The removal tool helps you remove geometry without the need to alter feature history or redefine any other number of features. For this demonstration, I want to use the remove feature to remove parts of these rounds. The first step is to select all the rounds. Now that all the rounds are selected, I want to click on the Editing tab and then click Remove. As of right now, the Remove feature wants to remove every single part of the rounds, but I want to keep these quarter rounds intact. So to do that, I'm going to click Options and then click in the Exclude Contour box and select the parts of the rounds I want to keep. You can press OK. The tool was able to delete the other rounds but keep the other rounds there. I was able to change the feature without being forced to redefine the feature or alter any feature history.
A flat wall is a planar, unbent section of sheet metal. Primary flat walls can take almost any flat shape because they're defined by a sketch. To create a flat wall, click Planar from the Shapes group of the Model tab. Select the datum plane top to sketch a wall, then sketch a shape that defines the size and shape of the flat wall. Click OK from the Sketch tab and enter a material thickness for the sheet metal wall. As you can see, it's pretty easy to create a planar sheet metal wall of any shape in Creo Parametric.
Here I have an imported dataset and I will use it to demonstrate how to replace trimming edges and show how to copy and paste a surface to a new location. First, I'm going to click on Import Data Doctor. Now I'm going to click on this front surface, and now I'm going to click on the Create pull down. Now I'm going to click on the UV Curves pull down and select UV Curve through points. Now I will hold Control and select these 2 points and press OK. Now I'm going to use the curve I just created to replace the boundary edge of this surface. So I will click on the existing boundary curve, select Replace, and now click on the UV curve I just made and click the check mark. Now I'm going to close all the current gaps in my geometry, so I'm going to click on Tools, Find. It's already set to look for gaps, and I'm going to change the value to 1 and press Find Now. Now I'm going to highlight all 5 of these gaps and move them over to be selected and press Close. Now I'm going to click on Import Data Doctor and select Add to Wireframe and then click Repair. Check off Repair Tangency and press OK. Now the last step is to copy this surface and use it to replace this missing surface. So I'm going to highlight the surface, then right click and select Copy. And now I'm going to right click and select Paste Special. And now I'm going to move this surface so that it's closer to where I want it to be. Now I'm going to click on the Placement tab, click on Select Component Item, and I'm going to select this vertice and select this vertice on the assembly. Now I'm going to click New Constraint, and again I'm going to click the corners and set one more edge so that it's fully constrained. Finish the placement. Now I'm going to highlight Surface 271 and Component 247 and click on Combine. Now I'm going to press OK to finish the Import Data Doctor and click OK to import it as a solid.
When working in flexible modeling, and you need to mirror geometry about a reference plane, head to the Transform ribbon group to find the Mirror tool. In this example, we're going to switch on the datum plane display and click in the Mirror Plane selection box to add the required reference plane. Similar to what you experience with the other flexible modeling tools, surfaces will be automatically extended and rounds will be recreated at the intersecting edges. Additionally, if we look in the Attachment tab, we can see some interesting options. You can control whether the rounds will be automatically recreated and if the mirror geometry will be attached or mirrored as an open quilt. Let's have a closer look at these geometry attachment options. If we unselect the Create Round Geometry checkbox, Mirror Geometry checkbox, instead of a rounded solid mirror feature, the result will be a mirrored open quilt of the selected surfaces. The Mirror tool provides you with several options to control how your mirror geometry will be created.
I currently have an incomplete model of an air engine intake, and what I am going to do is create surfaces to blend these parts together. To do this, I'm going to first click on the Style button, then click on Curve. I'm going to click on Free Curve, and I'm going to make 4 free curves between the two features. I'm going to hold down the Shift key when selecting my points so that it snaps to the point I want, and then click down on the screen. So I'll do this again, and one more time. And click the check mark. Now that my curves are created, I'm going to add constraints to the curve's endpoints to define the shape of the curves. So to do this, I'm going to click on Curve Edit, and I'm going to click an endpoint I want to change the constraint on. And this endpoint, I'm going to now make it normal, and I'm going to make it normal to this plane, so I'm going to click on the curve. I'm going to do this same constraint again on this endpoint. So I'm going to again click normal, and the plane. And notice again it changed the shape of the curve. Now for the rest of these endpoints, I'm just going to change it to be surface tangent. So again, just click on the curve, click on the endpoint, and select surface tangent. Now all my endpoints are completed, so I'm just going to click check. Now I'm going to create my surfaces. So the first surface I'm going to create is between these two curves. So I'm going to highlight them and then click on the surface button. Now I'm also going to highlight these two lines so that the curve is flush with those surfaces. And now press OK. Now my next surface, I'm going to highlight these two curves, then click on the surface tool. Now I'm going to also click on these two curves to set more boundaries for my surface, and that looks good. So I'm just going to click down on the scroll wheel to complete the surface. Two curves, again click on surface. I'm going to also highlight these lines so that they line up flush, and click OK. Now click OK to finish the surface, and there you see we created a blend between these two parts.
Assembling using automatic. In this task, we use the automatic option to assemble components. Disable all datum display types. Select Assemble from the Assemble Types drop-down menu in the component. In the Open dialog box, select component body.prt and click Open. Right-click and select Default Constraint. Middle-click to complete the component. Click Assemble. In the Open dialog box, select component shaft.prt and click Open. Reorient the assembly. Reorient shaft.prt approximately as shown. Notice that the constraint type is set to automatic. Select the surfaces. Notice that the system creates a coincident constraint. Select the two surfaces. Notice that the system creates an oriented constraint. Right-click and select New Constraint. Select the two surfaces. Placement tab. The constraint type to coincident. Middle click to complete the component. Click Assemble. In the Open dialog box, select component arm.prt and click Open. Reorient arm.prt approximately. Again, notice that the constraint type is set to automatic. Select the surfaces. Notice that the system creates a coincident constraint. Notice that the taper direction of the cones is not aligned. In the dashboard, select the Placement tab. Edit the constraint type to Centered. Enable Plain Display. Constraint. Select the two planes. Notice that the system creates an angle offset constraint. In the Placement tab, edit the constraint type to coincident. Middle click to complete the component. This completes the demonstration.
All drawings contain at least one sheet. When additional using the Sheets tab and dialog box functions can be accessed using the Sheet tab's area, located at the bottom of the interface. Thumbnail previews of each sheet are shown when the cursor passes over the tabs. You can easily navigate through or switch between sheets by clicking on different tabs. To create a new sheet, click New Sheet from the tab area and enter a name for the sheet in the text box at the top of the graphics area. Pressing Enter accepts the default name. Sheets can also be named or renamed by double-clicking their tabs. To copy an existing sheet, right-click on the sheet to be copied and then select Move or Copy. Then, in the Move or Copy Sheet dialog box, select where the sheet will be inserted and enable Create a Copy. Click OK and then press Enter to accept the default sheet name. The order of sheets can be easily changed simply by dragging their tabs to new positions. To delete a sheet, right-click on the Sheet tab and select Delete from the pop-up menu. Functions can be accessed using the Sheet tab's area, located at the bottom of the interface. Thumbnail previews of each sheet are shown when the cursor passes over the tabs. You can easily navigate through or switch between sheets by clicking on different tabs. To create a new sheet, click New Sheet from the tab area and enter a name for the sheet in the text box at the top of the graphics area. Pressing Enter accepts the default name. Sheets can also be named or renamed by double-clicking their tabs. To copy an existing sheet, right-click on the sheet to be copied and then select Move or Copy. Then, in the Move or Copy Sheet dialog box, select where the sheet will be inserted and enable Create a Copy. Click OK and then press Enter to accept the default sheet name. The order of sheets can be easily changed simply by dragging their tabs to new positions. To delete a sheet, right-click on the Sheet tab and select Delete from the pop-up menu. Many times there are different formats applied to different sheets in a drawing. To change the format used on a sheet, click Sheet Setup from the document group. You can then select the format that will be used on the current sheet. Creo Parametric enables you to easily create, configure, reorder, and delete sheets in your 2D drawings.
This technical tip is to discuss flow-dependent fittings and pipeline parameters in piping design. If we zoom into this pipeline here, you see that I've got a check valve, and the check valve indicates the direction of the flow. If I turn the flow direction, it's the direction of the flow. If I reverse the flow direction, i.e. the check valve does not currently reverse. To fix this, what we can do is we can select the fitting,